the factor theorem. Our objective here, let's use the factor theorem to solve a polynomial equation. In essence, solving means find the zeros. Okay, find the zeros of a polynomial equation. So what do we know coming in that we want to remember? We know the division algorithm. The dividend is equal to the divisor times the quotient plus the remainder. And when our divisor is linear, x minus a constant, our remainder is always a number. And we know the remainder theorem. Okay, if the polynomial f of x is divided by x minus c, then the remainder is f of c. Okay, we saw that. So, what happens if the remainder, if f of c is equal to 0? Well, if f of c is equal to 0, that means the remainder is 0. And then that tells us that x minus c must be a factor of the polynomial. And that's where the factor theorem comes into play. Let's see an example of this, and then we'll go down here to the bottom, and we'll put the factor theorem in words. Example, here's a second degree polynomial, x squared minus 3x minus 4. What is f of 4? We saw this in a previous video using the remainder theorem. F of 4 gives us the remainder. Okay, well, f of 4 is equal to, and again, I use parentheses. Okay, and if I do all this math, 16 minus 12 minus 4, I come up with 0. Okay, so f of 4 is equal to 0. So x minus 4, because I have a remainder of 0, I know that x minus 4 is a factor of the quadratic x squared minus 3x minus 4. Okay, we probably could have gotten that, maybe not. I'm not sure if we probably could have factored this and gotten that as well. But that's because this is factorable and because this is a quadratic, so it's fairly simple. But this tells us, is x minus 4 a factor? We put 4 in there. We use the remainder theorem. We got a remainder of 0, which tells us that we have a factor because we have a 0 remainder. So the factor theorem down here below says simply, when f of x is a polynomial, if f of c is 0, if we put in a number and we get a 0 out, then x minus c is a factor. Okay, it goes into the polynomial evenly. And similarly, if x minus c is a factor, then of course we put c in, we get a 0 out as the remainder. Okay, let's do a couple of examples taking a look at this. I've given you quite a bit of space. I've provided a lot of space for work. The two examples each have their own piece of paper, just because sometimes I know some students write a little bigger. And we've got a couple things to look at here that might take a little more space, but I just want to give you some space to work with this. So algebraically, we want to solve this equation. 2x cubed minus 3x squared minus 11x plus 6 equals 0, given that 3 is a 0 of this polynomial. Remember, solve, we want to find the zeros. We know 3 is one of them, okay? We're told 3 is a 0. Okay, so if 3 is a 0, the question is, are there any other zeros? Are there any other places where the graph hits the x-axis? So we know from the factor theorem, if 3 is a 0, then x minus 3 is a factor. Okay, So if 3 is a 0, then x minus 3 is a factor. So let's use synthetic division. Use synthetic division to find its other factor. It goes in evenly, so we know it's at least two things multiplied together. What is the other factor? Okay, so let's see. X minus c, so here's my 3. Okay, I have my polynomial here. X cubed, x squared, x is good, so my coefficients are 2, -3, -11, and 6. So 2, -3, -11, and 6. As you recall, this is row 1. And I'm going to have a row 2 and a row 3. And what I'm interested in is row 3. Row 2 is my calculations row. Underline. So what do? We pull the 2 down. We multiply. 3 times 2 is 6. We add. -3 plus 6 is +3. And we repeat until all columns are filled in. So 3 times 3 is 9. 9 goes here. Add. -11 plus 9 is -2. Repeat. 3 times 2 is -6. Add. -6 plus 6 is 0. Done. There is my 0 remainder. But I knew that was true because I was told that 3 is a 0. I knew that dividing this polynomial by 3 was going to give me a 0 remainder. What I wanted, this is the other factor. This, let's see, your quotient is the other factor. That's what I'm looking for, okay? So, I know here that 2x cubed minus 3x squared. Let me leave myself just a slight bit more room. I'm feeling like I'm a little bit squished here. I know that 2x cubed minus 3x squared minus 11x plus 6 is equal to, well, 3 is a 0, so x minus 3 is a factor. And the other factor is here, which is 2x squared. Remember, I'm 1 less than here, so these are my coefficients. Plus 3x minus 2. Okay? So I was able to factor this. I was able to factor this cube, this third degree polynomial, into these two factors, one of which is a quadratic. Well, I wanted to solve it for 0. Well, this makes things kind of nice. So in other words, I want to solve x minus 3 times 2x squared plus 3x minus 2 is equal to 0. And it's easier. How do I solve this for 0? I don't know how to solve a cubic, but I can solve a linear and a quadratic. Okay, so coming down, I know this tells me that x minus 3 equals 0, so x equals 3, but I knew that. I knew that up here, that 3 was a 0. So I knew that. This is just showing me here it is here, and here it is here. Okay, what I didn't know was the other possibilities, and they come from here. Okay, well, 2x squared plus 3x minus 2 is equal to 0. I believe this is factorable. This is 2x minus 1 times x plus, that's not correct. Let's make sure I get this right. 2x minus 1, let's see, plus times x plus 2. Let's double check this. Yes, this is 2x squared. 4x minus x is 3x and minus 2. That's good. So this is 2x minus 1 equals 0, or x plus 2 equals 0. Well, this one is x equals a half, and this one is x equals -2. So I solved it, right? I solved it. My solution set, going from least to greatest, is -2, +1/2, and +3. That's my solution set. These are the numbers that when I put them into here, I'm going to get 0 out. Let's take a look at this on our graphing calculator, okay, and see if we can get those same zeros. I'll go into here, I'll go into y equals, I need to clear something out. I know I'm going to do 2x cubed minus 3x squared. Graphing is always so much easier. Minus 11x than doing it algebraically. Well, not always, sometimes. Okay, let's graph that. Whoops, looks like I've got my window. So let's let it graph it. Okay, let's zoom to standard. Whoops, zoom, let's go back to the standard, -10 to 10. And here is my third degree polynomial. And you can see I have 3 zeros, 1, 2, 3. Well, where are they? Well, I'm saying there is 1 at -2, 1 at 1/2, and 1 at 3. I'm going to check this with my trace key, and I'm going to put in -2. That's a 0 right there. Now let's put in 1/2, 0.5. That's a second 0 right there. And now let's put in 3. And there's the third 0 right there. Of course, oftentimes the graph gives you a quick answer. Really nice. Okay? So there's how we can algebraically solve something. Of course, we're being told we're given a 0, and then we're using synthetic division to find the other part. And then we can factor that. In this case, it's turned out we're having a quadratic we're working with. Let's do a second example. So let me turn myself over here, turn the paper over, and let's go with that, get my notes together. Algebraically, okay, well, again, we'll check it with our, maybe I'll have you, let you check it. Algebraically solve this equation. 15x cubed, oh my goodness, plus 14x squared minus 3x minus 2 equals 0, given that we know -1 is a 0. So we know one of the zeros is -1. We don't know what the other zeros are, okay? But we know one of them is -1. So we know if -1 is a 0, right? Then x minus -1, right? X minus c, or in other words, x plus 1 is a factor. Okay, so we know one of our factors. The question is, what's the other factor? Okay, so we're going to take -1, and we're going to use synthetic division. I'm going to abbreviate it as SYN, division, to find the second factor. Okay, I know that -1 is a 0, so I'll draw my box. My third degree polynomial is in order. I'm not missing any x terms, so I'll use the coefficients. 15, 14, -3, -2. And again, this is row 1. Row 2 is my math row. Row 3 is my answer row. Okay, and let's go. Pull the 15 down. We know I multiply. -1 times 15 is -15. And then I add 14 plus -15 is -1. Repeat. -1 times -1 is +1. Write it in this column. -3 plus 1 is -2. Repeat. -1 times -2 is +2. Write it in the fourth column. Add, I get a 0. Well, I knew that was going to happen because I knew that -1 is a 0, so that x plus 1 is a factor, and this shows it here. What I'm after is this. This is the other factor, the coefficients of the other factor. Okay, so I know that 15x cubed plus 14x squared, I'm simply copying this, minus 3x minus 2 is equal to x plus 1 times, and again, these are the coefficients of a squared of a second degree polynomial, times 15x squared minus x minus 2. Okay, that was my goal. I wanted to break this down into some easier polynomials to work with. Okay, so now my question is not solve this, my question is solve this. Okay, my question is x plus 1 times 15x squared minus x minus 2. I can solve this. Well, we know the first one. This one is x plus 1 equals 0, so I know that x equals negative 1. That's a 0, but I've already now been told that once. Here's the told once. Okay, I proved it with a synthetic division. That one I knew. I don't know the other two. Well, it turns out that this is factorable. Okay, this is 15x squared minus x minus 2. That we want that equal to 0. That's factorable as 5x minus 2 times 3x plus 1 equals 0. Let's see, 15x squared plus 5 minus 6 is minus 1, and there's my minus 2. So I have 5x minus 2 is equal to 0, or 3x plus 1 is equal to 0. Add 2, divide by 5. This is x is 2/5. Subtract 1, divide by 3. This is x is negative 1/3. So in this case, the polynomial, this third degree polynomial, touches the x-axis 3 times. And so I want to solve it. Solve it means where the 0 is located in numerical order from least to greatest. Negative 1 is the least. I did not negative 1/3. Negative 1, negative 1/3, and positive 2/5. Those three numbers will make this true. Takes a little work. It's bringing together a number of things for us. Take your time. Notice I'm using a lot of paper. You're welcome to use paper to keep yourself straight. There aren't a lot of shortcuts. Otherwise, you can make mistakes, and you'll be just fine.